consider a molecule which is an important beta blocker and one of the most prescribed drug on the list of World Health Organization. This molecule is known as Propanolol, which is famous by its trade name of Indrol. Especially this drug is used for treatment of high blood pressure. We will subject propanolol into different retrosynthetic analysis by making different disconnection, and in the end we will check out which retrosynthetic route is feasible on commercial scale. So let me first make a disconnection right at this point by calling it a disconnection A. I am numbering it as number 1 and number 2. I will get 2 syntones. By placing a positive charge right over here, it is carbon number 1 and this is carbon number 2. So this is an acceptor syntone because it has a positive charge. We call this acceptor syntone as A2 because we have a positive charge on 2. Another syntone will be like this, in which we have a negative charge on nitrogen atom, and this synthetic equivalent of isopropylamine and not difficult to predict because we place a negative charge on nitrogen because it is more electronegative, therefore it is donor syntone. As the negative charge is nitrogen, therefore it is known as D1 syntone. So the synthetic equivalent for acceptor syntone can be deduced as we have positive charge on carbon number 2. Here we have a lone pair of nitrogen. The bond can be shifted right over here for making an epoxide. Therefore we get a reagent like this, and another is isopropylamine. This reagent can further be disconnected at this point and we will get 2 syntones. Again a negative charge on oxygen. This is the donor syntone, which is equivalent for one naphthol, and the another reagent, let me draw it over here. By placing a positive charge right over here because I have placed a negative charge on oxygen, therefore this structure can be equivalent for a chlorine epoxide. Let me call it a reagent A. If propanolol is our target molecule, therefore now I am considering a second retrosynthetic route. Let me consider the target material and subject me into a functional group interconversion. I will get Here I have incorporated a carbonyl oxygen so that I could get an amide-like functionality. Now it is easy to make a disconnection at this point. I will get two syntones. By placing a positive charge on carbonyl oxygen, and then another is isopropylamine, which is easy to predict. Therefore, I have directly sketched it as an isopropylamine. As far as the acceptor syntone is concerned, we can make a reagent by placing a chlorine atom on the positive charge. So its equivalent reagent will be this one. This can further be subjected to a disconnection at this point. Let me call it carbon number first and number 2. I will get two syntones again. By placing a negative charge on oxygen, which is equivalent for 1-phtol, and another syntone will be like this one. So as we have positive charge, therefore nitrogen is electronegative and it has a lone pair of electrons. You can shift right over here for giving a synthetic equivalent of an epoxide which has a carbonyl group next to it. Let me call it a reagent B. Now we have subjected propanolol to two different synthetic routes, synthetic route A and synthetic route B. Now we will check out which route is simple and give us simple sorting material. As far as the reagent A is concerned, it is readily available, especially on commercial scale, but as far as reagent B is involved, this is not readily available, it cannot be made easily. Therefore we choose route number first as a viable route, unlike route number second, because the availability of reagent B is not possible, or it cannot be made easily. So that's why we use route A for synthesis of propanolol, and in fact propanolol is commercially synthesized via route A. Consider the forward synthesis. Let me react naphtol when I treated it with the base. I will get a phenoxide which will be reacted with the reagent A. So here let me clarify it. We have two carbon atoms because the phenoxide will perform an SN2 reaction. Either it will react at this carbon atom via an SN2 reaction, or it will react at this carbon atom again at an SN2 reaction. Now the question is which carbon atom is more reactive, especially the carbon of epoxide is more reactive. Therefore the reaction will take place at this carbon atom, let me call the entire molecule as an acetate. So the acetate will add, let me correct it, this carbon atom, oxygen will acquire a negative charge. I am going for writing a mechanism. And here I have an acetate, especially the phenoxide will attach it right over here, and again this negative charge will attack this carbon in SN2 fashion by expelling a chlorine atom. Therefore we will get an epoxide like the above molecule. Let me number first. So I will get this product right over here. And finally this product is reacted with isopropylamine, which will react at this position again via an SN2 reaction, and we will get to the target material. So this is how we can synthesize propanolol. Let me clarify